So let's look at another integration method. This is integration with inverse trig, and it's basically another way to use U-sub, except with inverse trig. So these are the three formats of integrals that we're going to look at. So the first one we have 1 over square root a squared minus u squared du, and this is going to be equal to arc sine of x over a plus c. And the next one we have is the integral of 1 over a squared plus u squared du, and this is equal to 1 over a arc tan x over a plus c. And the last one we have is 1 over u square root u squared minus a squared du, which is equal to 1 over a arc secant of absolute value x over a plus c. And we're going to be looking at some problems and solving them using these three formats. Question 1 we have, find the integral of 2 over square root 4 minus 9x squared dx. So this looks really similar to arc sine. So what we're going to do is set this equal to a squared and this equal to u squared. So u squared is equal to 9x squared. So if we take the square root, we're going to have u equal to 3x. And now, since u is a variable, we're going to have to differentiate this. So du over dx is equal to, the derivative of 3x is just 3. And now we're going to have to solve for dx. So if we just cross multiply, we'll get dx is equal to du over 3. Now let's set 4 equal to a squared. So a squared equals 4. And if we take the square root, it's going to be 2. And since a is just a constant and not a variable, we don't have to differentiate this. So now we have all information, and let's plug it back into the integral. So the integral of 2 divided by square root, and we said 4 was a squared, and we said 9x squared was u squared, so minus u squared, and we said dx was equal to du over 3. And since 2 and 3 are just things being multiplied to this entire thing, we can move it out of the integral. So we have 2 over 3 multiplied by 1 over square root a squared minus u squared du. Now we have this in that form. And 2 over 3 is just being multiplied by the entire thing. So we can just set this equal to 2 over 3 arc sine, and it was arc sine of u over a. And we said u is 3x and a is 2. So 3x over 2 plus c. And that is our final answer. So number 2 we have, find the integral of 8 over x square root 4x squared minus 1 dx. So this looks really similar to arc secant this time. So what we're going to do is set this equal to u squared and this equal to a squared. So u squared is equal to 4x squared. U is equal to 2x. And now we have to differentiate this. So du over dx is equal to, the derivative of 2x is just 2. And we're going to solve for dx. So dx equals du over 2. Now 1 is going to be a squared, and the square root of that is just 1. And we don't have to do anything after that because it's just a constant. Now let's plug everything back. But first let's move 8 outside. 8 multiplied by 1 over x square root. 4x squared we said was u squared. And 1 we said was a squared, so minus a squared. And dx we said was du over 2. And let's move this 2 outside as well. Actually, we'll keep it in for now. But here, we can't use that arc secant formula yet because this is in terms of du, but we still have an x here. So we need to get rid of that. But fortunately, we already set u equals to 2x. So all we have to do is solve for x here. So let's just draw an arrow saying x equals u over 2. Now let's rewrite this and say 8 integral of 1 over x is u over 2, so u over 2 square root u squared minus a squared du over 2. Now we can cancel off these 2's, and now we're left with 8 integral of 1 over u square root u squared minus a squared, and du. Now this is perfectly in that format to use arcsecant. So we can just set an equal sign to this. And remember, arcsecant is multiplied by 1 over a. But since a is just 1, we can just keep it like, at 8. And then arcsecant of absolute value of u, which is just 2x, divided by a, which is just 1. So it's just 2x plus c. And this is our final answer. Number 3, we have find the integral of 3 over 25 plus x squared dx. Now this time, it looks very similar to arctan. So we're going to set u squared equal to x squared. So u is equal to x, and du over dx is equal to just the derivative of x is just 1. So dx is equal to du. So nothing really changed there, but let's set a squared equal to 25. So a is equal to 5. Now we can plug everything back in, but first let's take 3 out. So 3 integral 1 over a squared plus u squared, and dx is just du, so nothing changed there as well. So this is already in the format, so we can just say, set equal sign, but since this is arctan, this is going to be divided by a. So a we said was 5, so 3 over 5 arctan, and then this is u over a, and u is x, a is 5, so x over 5 plus c. And this is our final answer. Question 4, we have find the integral of x minus 3 over x squared plus 1 dx. So at first glance, this doesn't really fit with anything we have yet. But what we can do is, since the top, it has 2 terms, we can actually separate this integral. So we can say this is equal to the integral of x over x squared plus 1 minus the integral of 3 over x squared plus 1, and then this is dx dx. So now we can evaluate these separately. So let's look at this one first. So let's draw an arrow. So let's solve this one first. And even after we split, this still doesn't look like anything that we've used before. Even though we have an x squared plus 1, which was arctan. But the problem is we have an x in the top. So if we try to set, let's just see what happens. If we try to set u squared equal to x squared, and u is x, du over dx equals 1, du equals dx, and then a squared equals 1, a equals 1. And if we try to put this into the integral, watch what happens. We'll get x over u squared plus a squared du. But this x we can set it as u, but even then, the most we can get to is just u over u squared plus a squared du. And we can't set this as arctan, but because we still have a variable on the top. This is supposed to be 1. So we have to see, how can we get rid of this u? Well, the solution to this is, instead of setting the U-substitution with the arctan 1, we can just do regular U-substitution and set the whole thing as u. So let's look at how that's done. So let's set u equal to x squared plus 1. And then let's differentiate this. So du over dx. And the derivative of x squared plus 1 is just 2x. And let's solve for dx. We have dx is equal to du over 2x. And for now, we're not going to have any a. So now let's just put this into the integral. So integral of x over, and we said x squared plus 1 is just u. And then this is du over 2x. And now, if you see here, we can actually cross off these x's. So we crossed off the x's and we're just left with 2, which we can just take to the outside. So we just have 1 over 2, integral of 1 over u du. And now this is a lot more familiar because the integral of 1 over u is just ln u. So let's go up here. This is just going to be 1 over 2 ln absolute value u plus c. But since we started off with x, we have to end with x. So u we set as x squared plus 1. So this is just going to be 1 over 2 ln absolute value x squared plus 1 plus c. But this is not our final answer. This is just half of it. We have to evaluate this part too. The negative of integral 3 over x squared plus 1 dx. But this is a lot more simpler because, let's just separate this for now. This is going to be 3 integral 1 over x squared plus 1 dx. And this is perfectly in the form to just do regular arctan. So u squared is equal to x squared. And then u is equal to x. Du is equal to dx. And a squared is equal to 1. A is 1. And now let's plug everything in. 3 integral 1 over u squared plus a squared du. This is equal to 3 over 1, which is just 3, arctan of u over a, which is just x, plus c. Now we have to combine both of these, but actually there's a negative here, so this should be negative. So now let's combine both of these. So the answer is just going to be 1 over 2 ln absolute value x squared plus 1 minus 3 arctan x plus c. And this is now our final answer. Question 5, we have find the integral of 1 over x squared minus 4x plus 7 dx. Now this is an even weirder format than last time because this is a trinomial in the denominator, which doesn't fit with any of our things. But we can still actually use it. But first we have to manipulate the integral a little bit. So first we need to get this into a form where we have u squared and an a squared, where we only have 2 terms. So to do that, we have to complete the square in order to factor this. So let's just do that over here. So x squared minus 4x plus 7, and that's going to equal 0, just for now. And we're going to move c, because this is in the form ax squared plus bx plus c. And we're going to move c outside. So x squared minus 4x equals negative 7. And we're going to take b divided by 2 and square that. So b over 2 is 4 over 2, which is 2. 2 squared is 4, so plus 4. And now we can factor this because this is just x minus 2 squared. And since we added 4 here, we're going to add 4 here. So this is equal to negative 3. And we're going to move this back, so this is going to be plus 3 equals 0. Okay, now that we have our new function here, all we're going to do is make the integral 1 over x minus 2 squared plus 3 dx. Now we can use the arctan. So u squared is equal to x minus 2 squared. U is equal to x minus 2. Du over dx is just 1. So du is equal to dx. A squared is equal to 3. So a is equal to square root 3. Now let's plug everything back into the equation, or the integral. So we have the integral 1 over, we said that x minus 2 squared is u squared. So u squared plus 3 we said was a squared, so a squared. And dx is just du. So now we can set this equal to 1 over a, which is 1 over square root 3, arctan of u over a, which is just x minus 2 over square root 3 plus c. And this is our final answer.